What if I told you that every time you hit a putt just a tiny bit too hard, the physical golf hole actually shrinks by half an inch?
I mean, I know it sounds like a magic trick, but it is pure, unavoidable physics. And it's really the reason so many players walk off the 18th green just completely defeated.
It really is this uniquely frustrating reality.
Mm.
Like, if you spend any time on a golf course, or really, if you've ever tried to master any precision physical skill, you know the exact feeling.
Oh, absolutely.
You read the green perfectly,
Yeah.
you align your shot flawlessly, you stroke the ball right on your intended line, and you still watch it lip out and miss.
Yeah, it drives people absolutely crazy.
It does. And why does that happen? Well, because almost everyone is obsessing over the exact wrong variable. We are out there agonizing over direction when the real secret to lowering your score is all about speed control.
Right. We fall victim to what I call the illusion of alignment. We like to treat putting as this binary geometry problem, drawing a straight line from point A to point B.
Like a math test.
Exactly, but direction is only a fraction of the equation. If your speed control is off, well, your perfect read is entirely useless. The ball simply will not behave the way you mapped it out in your head.
Okay, let's unpack this. Because our mission for this deep dive is to look at a rigorously data-driven approach to putting. Specifically, we're analyzing the Putt system, which you developed.
That's right.
We are diving into the hard data to prove why length and speed control, not alignment, is the single most critical factor in performance. The goal here is to turn putting from this subjective, guesswork-heavy art form into a measurable neurological science.
And to even begin doing that, we first have to fundamentally redefine what a putt actually is. Most people, they think of a putt as a purely mechanical action.
Right, you take a piece of metal, hit the ball, and hope you aimed right.
Exactly. But if you really want to understand speed control, you have to look at it as an exercise in physics. It is pure energy transformation.
Which is fascinating. The research breaks this down into 3 specific types of energy that are all interacting the second you move the putter. First, you have kinetic energy.
Right, the stroke itself.
Yeah, the actual physical energy you were putting into the golf ball. Then you immediately run into dissipated energy, which is the friction from the grass actively slowing the ball down.
Yes, and finally you have potential energy. That's the influence of the slope and gravity pulling the ball sideways off its straight line.
So from a coaching standpoint, that means a player isn't just hitting a ball.
No, not at all. They are doing 3 distinct things simultaneously. They're managing energy input through their stroke length and rhythm. They're understanding energy loss by reading the friction of the green. And they are predicting energy transformation by, anticipating how gravity will alter the path.
Why?
Every single putt is an energy management task. I mean, it has almost nothing to do with whether your elbows are perfectly tucked or your stance is exactly shoulder width apart.
Wait, hold on. I have to push back on that.
Sure.
Because instead of swinging a hammer to hit a nail, you're telling me I have to think of it like solving a dynamic, multivariable math equation on the fly.
Wow.
I mean, I'm out there on a Saturday afternoon with my friends. There is zero chance my brain is doing calculus over a standard 10-foot putt.
What's fascinating here is you actually are doing that math, just not consciously.
Really?
Yeah. Elite players aren't standing over the ball crunching numbers like a supercomputer. What they have done is train their neurological systems to instinctively manage those energy variables. The math is absolutely happening, but it's happening in the subconscious, specifically in the cerebellum.
Okay, so they've internalized the math.
Exactly. The problem with the average weekend player is that they try to consciously force the physical mechanics. And the moment you introduce conscious mechanical anxiety, you completely disrupt the brain's natural intuitive ability to calculate distance and energy.
So the goal is to basically get out of our own way. But if putting is really about managing energy, and we want to take this out of the realm of pure feel, we need a precise, measurable target. What does, perfect energy actually look like at the moment of truth?
Well, the data provides an incredibly specific metric for this. We call it the ideal capture speed.
Right.
And it is exactly 3 to 4 revolutions per second, or RPS, as the ball arrives at the hole.
That is the golden metric. Right. Just to ground it in reality for everyone listening, 3 revolutions per second is a ball moving at about 0.9 meters per second.
Yep, and 4 RPS is about 1.2 meters per second. That is the exact speed window where the physics of the hole actually work in your favor.
And the reason for this comes back to my opening question about the physical dimensions of the hole. A standard golf hole is exactly 3.5 inches wide.
Right.
But the data reveals this incredible reality. Every single additional revolution per second beyond that ideal 3 to 4 RPS speed effectively shrinks the physical hole by about half an inch.
It does, because gravity needs time to act on the ball. If the ball is rolling too fast, gravity literally cannot pull it down into the cup before its momentum carries it, skipping over the back edge.
That makes so much sense.
Let's say you hit a putt that arrives at the hole spinning at 9 revolutions per second. Your margin for error just dropped to nearly 0. It has to hit the absolute dead center of the pin to drop in.
Right.
But if you deliver the ball at that 3 to 4 RPS window, the hole basically plays larger. You can hit the left or right edge, and gravity still has enough time to capture the ball and pull it down.
Which completely debunks a very common piece of advice you hear from amateurs. People always say, I'm going to hit it firm to take the break out of the putt.
Well, I hear that all the time.
Right. The logic is that if you hit it hard, it won't have time to curve, so you can just aim straight at the cup.
And it is one of the most destructive myths in the game. Yes, hitting it harder reduces the curve. That part is true. But as the math clearly shows, hitting it firm literally shrinks your target.
You're shooting at a smaller hole.
Exactly. You are trading a slightly easier read for a target that is suddenly the size of a thimble. This isn't a subjective philosophy about how you should play the game. It is a hard performance parameter. If you consistently arrive at the hole at 3 to 4 RPS, you will make more putts simply because you are playing with a bigger hole.
Okay, having the mathematical target makes perfect sense. But knowing the target and actually getting the human body to deliver that exact speed consistently are two very different things.
Very different, yes.
So how do we actually program that intuitive math engine in our cerebellum so we aren't just guessing out there?
Well, the system outlines a progressive series of 3 core exercises to achieve this exact neurological calibration. The entire point is to strip away the visual interference and the mechanical anxiety and will train the body to feel the rhythm of distance.
The first exercise is called sensory calibration, and the setup sounds a bit wild. You take 3 balls, and you make your putting stroke completely blind.
Right, totally blind.
You literally do not look at the ball. And then immediately after you stroke it, you turn your head 90 degrees to the side. You're supposed to do this for about 4 to 6 minutes, right?
Yeah, it sounds strange, but from a neurological perspective, it is brilliant. By removing your vision, you are forcing your cerebellum to map the speed of the green using pure proprioception.
Proprioception meaning your body's internal sense of its own motion, rhythm, and balance, right?
Yeah.
Like how you can touch your nose with your eyes closed.
Exactly. When your eyes are open, your brain uses visual data to judge distance. If you look up to track where the ball went, your brain instantly judges the success of the putt based on what it sees.
Ah, I see.
By keeping your eyes closed and turning your head 90 degrees, you cut off that visual feedback loop entirely. You force your brain to judge the distance only by how the energy input of the stroke physically felt in your hands and arms. It calibrates your internal perception of distance without the noise of visual anxiety.
So you are isolating the raw physical sensation. Once your brain starts feeling the stroke rather than seeing it, the system moves to exercise 2, which is all about instinct limitation. You set up a fairly long putt, maybe 15 to 20 meters away. You look at the hole, and you swing only as far as your pure, unthinking instinct allows.
Yes.
And the result, according to the data, is almost universal. The ball will fall short every time. Why does our instinct betray us like that?
If we connect this to the bigger picture, this is actually profound. The reason you fall short isn't a mechanical flaw, it's evolutionary biology.
Biology.
Yeah, the human brain has a built-in protective instinct. Evolutionarily, our brains are wired to be cautious. We inherently avoid perceived risk. In the context of a golf course, blasting the ball 15 feet past the hole into the rough is perceived by the brain as a threat.
Like a massive failure.
Exactly. So your subconscious literally hits the brakes. Golfers naturally underhit long putts because of this protective programming. You have to consciously expose this limitation before you can correct it.
Which perfectly sets up exercise 3 overcompensation. You take the exact same 15 to 20 meter setup, but this time you intentionally swing well beyond that protective instinct so the ball deliberately rolls too far.
That's the one.
It's basically like calibrating an oven dial.
Yeah.
By deliberately feeling what is too short, your natural instinct, and then deliberately feeling what is too long with the overcompensation, you're mapping out the boundaries.
The oven dial is a great way to think about it. You are defining the upper and lower boundaries of energy input for your brain. Once your nervous system knows what too much energy feels like and what too little energy feels like, well, the optimal stroke naturally slots right into the middle.
You're forcing the brain to learn the scale.
Yes, you are effectively rewriting your brain's risk-averse programming to trust a specific, calibrated speed window.
Here's where it gets really interesting. Once you have that internal neurological calibration locked in, you have to apply it to the external environment of the golf course. And the environment behaves in deeply counterintuitive ways.
It really does.
The data highlights a massive paradox when it comes to green speed and how much a putt breaks.
Ah, yes, the time and break relationship. This is where a lot of players' intuition completely fails them, no matter how well they strike the ball.
Right.
The absolute rule of the system is that the speed at the hole must remain constant at 3 to 4 RPS. And that's regardless of whether you are playing on lightning-fast tournament greens or slow, fuzzy municipal greens.
Let's walk through the logic of this paradox slowly, because it completely breaks the average player's mental model. Let's say you are on a very fast green. Because the friction of the grass is so low, you have to hit the ball much softer to arrive at the hole at our target of 3 to 4 RPS.
Correct. And because you hit it softer, the initial speed of the ball as it travels across the green is slower.
And because it is moving slower overall, it spends more time on the slope, which means gravity has more time to pull it sideways. Therefore, on a fast green, the ball breaks more.
Yes, exactly. And conversely, on a slow green, the friction is high. You have to input a lot more kinetic energy. You have to hit it harder just to get it to the hole at 3 to 4 OPS.
Okay, so it's moving faster.
Right. Because the ball is moving faster to overcome that friction, gravity has less time to pull it down the slope, so it breaks less.
Fast greens equals slower ball speed, which equals more break. Slow greens equal faster ball speed, which equals less break. That is completely the opposite of what your gut tells you.
It really is.
You stand on a fast green and think, fast green, fastball.
And that intuition is exactly why so many putts miss the hole. The Puttalize app actually simplifies this complex physics by separating your aim from your distance. It basically treats every single putt as if it were on a perfectly flat surface by creating an aim point and a distance point.
Explain how those 2 points work.
Sure. So your aim point is simply the direction on the fall line. The straightest path water would take down the slope. That is where you start the ball. But the distance point is your energy target. So if you have an uphill putt, the app calculates that your distance point, the amount of energy you need to input, is actually several feet past your aim point.
Because you need more power to get it there.
Exactly. For a downhill putt, your distance point is shorter than your aim point. You aren't trying to, quote-unquote, hit the hole anymore. You are delivering a specific amount of energy to a theoretical distance point and letting gravity do the rest.
You are totally separating the geometry of the slope from the physics of the energy.
Yeah.
That makes sense. But, and this is a massive but, you can have perfect neurological calibration. You can perfectly understand the paradox of green speed. You can calculate your aim point and your distance point flawlessly.
Right.
And there is still one final glaring variable that can ruin absolutely everything: the physical putter in your hands.
Ah, the equipment blind spot. It is amazing to watch players spend countless hours tweaking their physical mechanics, taking lessons, reading greens, while completely ignoring the launch conditions of their primary tool. Speed control is highly, highly dependent on the equipment itself.
Let's look at the launch condition data, because it's wild. First, we have loft. If your putter has too much loft, it creates a higher launch angle for the ball. And a higher launch creates massive variability in speed, because the ball is physically bouncing and skidding on the grass before it starts rolling smoothly.
Yes, skipping kills your speed control.
Second, you have face rotation. For a consistent stroke, the twisting of the putter face must be kept under 15 degrees per second. If your putter face is twisting wildly through the impact zone, your energy transfer is going to be completely erratic.
And then there is face angle at the exact moment of impact. That is responsible for approximately 92% of the ball's start direction.
92%.
Yeah, if the face is open or closed by even a fraction of a degree, you miss that aim point we just talked about entirely.
But the statistics on player awareness regarding this are staggering. The data shows that roughly 90% of golfers do not even know their putter's loft. And between 95 to 99% of golfers do not know their lie angle.
This raises an important question, doesn't it? Why are we treating golf like a guessing game when the tools we use are built on precise engineering?
Just to clarify for anyone unfamiliar, the lie angle is the exact angle the shaft goes up from the putter head, right? Which completely alters how the club sits flat on the grass.
Exactly. If your lie angle is off by even a couple of degrees, The toe or the heel of the putter digs into the turf, or it strikes the ball off center. If 99% of players don't know the lie angle of their putter, they are fundamentally disconnected from the launch conditions that dictate their speed and direction.
So it's like trying to perform microscopic neurosurgery using a scalpel when we don't even know if the blade is sharp or bent.
That's a perfect analogy. A poor setup with your equipment leads to inconsistent launch conditions. Inconsistent launch conditions directly compromise the quality of the roll. And if the roll is compromised, your speed control is gone.
Wow.
It doesn't matter how well your cerebellum is calibrated if the tool itself is sabotaging the energy transfer.
So what does this all mean? If we step back and look at this entire data-driven approach, it requires a monumental shift in mindset for anyone who wants to perform at an elite level.
It really does.
You have to stop trying to mechanically hit the ball to a visual distance. Instead, you have to create a consistent physical rhythm, understand the physics of energy transfer, optimize the engineering of your putter, and then let your calibrated body deliver the distance instinctively.
It changes putting from a forceful, anxious action into a rhythm-based sensory experience. Speed control is trainable. It is absolutely measurable, but you have to do the quiet work.
Right.
You have to train your perception by putting blind. You have to understand your instinctual limits, expand your energy range with overcompensation, and ensure your equipment matches your stroke. It is a complete holistic system.
It really is.
Right.
And, the applications for this kind of thinking go so far beyond a golf course.
They do, and that's perhaps the most compelling part of all this data. Consider how much of our physical performance, and really not just in golf, but in any learned skill, whether it's playing a musical instrument, speaking in public, or even navigating a difficult conversation, is secretly being sabotaged by our brain's innate protective instinct.
That fear of going too far.
Exactly. We are biologically wired to hold back, to leave it short, to avoid perceived risk. If our own minds naturally make us fall short to protect us, then mastering any art isn't just about learning the right technique. It's about having the courage to actively unlearn our own survival mechanisms so we can finally find our perfect rhythm.